Hello students, welcome back once again for our online sessions, and we were in chapter number 2, linear equations in one variable. So I hope till now whatever we have done, you have given revision, you have solved the assignments, children. So let us begin with our today's session of mathematics, that is chapter number 2, linear equations in one variable. So you can see few expressions are there on your screen. The first is 2x. So these are expressions, algebraic expressions, children. So I can see only one variable in this, that is x. You can see here. So this is expression, this is one variable, right? And the power of the variable is 1. So hence it is a linear expression in one variable, right? The next one also you can see 5 upon 4 into x minus 4. So here also you can see only one variable is there and the power of the variable is also 1. So this is a linear expression, right, in one variable. Now this is again 3y minus 7. Again this is the one variable, that is y, and the power is again 1. So this is a linear expression in one variable. Now the last one you can see, children, it is x square plus 1. So this is one variable here, but the power of the variable is 2, that is it is x square. So hence it is a non-linear expression. Okay, since the power is more than 1, we say it non-linear expression. But in our chapter we are going to deal with the linear equations in one variable. Now these all were the expressions. Now what is the equation? Let us see. So let us briefly see. An algebraic equation is an equality involving variables, children. So it has a equality sign. So here you can see the equality sign present over here. So you can see here, children, it is 2x minus 3 equal to 7. So it is the expression towards the left hand side of the equality sign is known as LHS, that is left hand side, and the expression on the right of the equality sign is known as right hand side. So here 2x minus 3 is on the left hand side and 7 is on the right hand side of the equality sign. So this is known as an equation, linear equation in one variable. Now one variable, since there is only x as a variable, only one variable. And why it is linear? Because the power of the variable is 1, not more than 1. So this is a equation, algebraic equation, linear equation in one variable. So I hope you understood. Let us proceed. This is just a revision, children. Yeah. In an equation, the value of the expression on the left hand side and right hand side are equal. So always the value to the left hand side and right hand side should be equal. This happens to be true only for a certain values of the variables, and when we find that value of the variable, that is known as the finding the solution of the equation. So always, children, till now you have done exercise 2.1, 2.2 and 2.3. So everywhere you have seen that either the equation will be given and we are finding the value of the variable, else in the word sums we form an equation and then find the value of the unknown variable. That is nothing but we are finding the solution of the variable. And how we check our answers? We substitute the value of the variable in the given equation and then we can see that left hand side is equal to right hand side. So this is the thing, that is a solution. Now next is how to find the solution of an equation. So we have seen different methods to find the solution, children. So let us briefly and quickly see that. So the very first method what we have seen is by addition or subtraction and multiplication or division on the both sides. Okay, so for example here we can see Yeah, it is 2x minus 3 equal to 7. Now what we do is one by one we cancel the constants present with the variable. So here you can see left hand side it is 2x minus 3. So if I add 3 both the sides, this plus 3 and minus 3 gets cancelled and only 2x is remaining to the left hand side. And the right hand side 7 plus 3 is 10. So we add or subtract any of the constant you are doing, you have to do on the both the sides, right? Or else dividing to the both the sides, and this is how we find the solution of a expression or the equation. Now next, later on we get 2x equals to 10 equal to 10. Now later on we can see here it is 2x. So 2 is present with the variable. So if it is in the multiplication form, if we divide by 2, 2 and 2 gets cancelled and only x will remain in the left hand side. So I really dividing 2 both the sides by 2, it is 2x upon 2 equal to 10 upon 2. That is nothing but x equals to 5 is the solution. And when we substitute this x equal to 5 in our given equation, you will see that left hand side and right hand side are equal. So this is the first method we have seen. We said balancing also, right? Next is by transposing. Now transposing is nothing but we transpose the constants to the other side by changing the sign. That is, if it is in positive, it is in plus, it goes to the other side and it becomes negative. If it is in division, it goes to the other side and becomes multiplication. So this is the example, children. You can see a simple example here. X minus 3 equal to 7. Now this 3 is negative 3 is present with the x along with the variable here. So if I transpose 3 to the right hand side, it will become plus 3, that is 7 plus 3. So it is x is equal to 10. So this is the another method which we have seen. You have also solved an n number of sums, children. And the last one is combination of both the methods. So wherever you feel easy, you can use both the combinations, or you can just use the transposing, or you can just do by addition, subtraction or multiplication and division on the both the sides, right? So these are the methods, 3 methods which we have seen, children. So now I hope you have everything is clear. So let us begin now with our next exercise, that is exercise 2.4. So here is the question number 1. Again we are going to see the word sums, right, children? So yeah, the first one is Amina thinks of a number. Amina thinks of a number. Now which number? We don't know. So here suppose I take Amina thinks of a number is x and subtract 5 upon 2 from it. So from x I subtract 5 upon, sorry, it is 2, right? Now should I write it once again? This is x. Amina think of a number and we subtract 5 upon 2 from that number, right? Then she multiplies the result by 8. So whatever result comes, we are going to multiply it by 8. And then the result now obtained is, after solving this whole thing, the result which is obtained, that is equal to 3 times the same number she thought of, that is Amina thought of, right? 3 times means 3 multiplied by, times means multiplied by. 3 times the same number. Which number now here? X, right? Amina thought a number which we have taken as x. So I'll write here x, 3x. Now what is that number? That is the x value we have to find over here. I hope the equation is very clear, children, how we got this, how we have formed the equation. So let us see the solution. Yeah. So now you can see over here the equation what we got. 8 into multiplied by in the bracket x minus 5 upon 2 is equal to 3x, right? First of all, we are going to open this bracket. Now open the bracket means 8 will be multiplied by all the terms in the bracket. So 8 into 8 will be 8x and 8 into 5 upon 2, that will be 8 into 5 upon 2 is equal to 3x as it is to the right hand side. Now here 8x as it is in the next, and 8 5s are, now you can directly do the multiplication and then divide or cancellation. Here you can do as you wish, children, whichever you feel is easy. So any method you can use. So here they have cancelled here. So 2 1s are, 2 4s are. So in numerator is negative 4 into 5, that is 20, right? Next is, or else you can do 8 5s are, yes, 40 divided by 2, which is again equal to 20. So this also you can do, right? So again let us come. So here is 8x minus 20 equal to 3x. Now 8x, so now here you can see, now here we have 8x and here we have right hand side 3x. Now what we'll do is we will bring all the terms which consist variables to one side and all the constants to the other side. So we transport 3x to the left hand side. So it becomes positive 3x becomes negative 3x. So it is 8x, right? Now here you can see it is 8x minus 3x is equal to 20. Now 20 is shifted to the right hand side. Negative 20 becomes positive 20. So 8 minus 3 is 5x. 5x equals to 20. Now 5 is the constant present with the variable. We transport 5 to the other side. Then multiplication form, it goes to the right hand side, it goes in the division form. So it is x is equal to 20 divided by 5, which is equal to again 4. So hence the number which Amina thought of is 4. Number 4 is the solution. How to cross check, children? You can substitute the value of the 4 in the given equation and check whether left hand side is equal to right hand side. Okay, so this you can do later on. So this was our first question. Let us proceed. Let us see one more example today. So this is the next question now. A positive number is 5 times another number. Now what another number? We don't know. So let us take that another number as x. So let us take another number as x. So what will be the positive number, children? Yes, positive number is 5 times the another number is, that is nothing but 5x. So here we got two numbers, that is one is x and one is 5x. If 21 is added to both the numbers, so both the numbers, if I add 21, here is x plus 21 and here is 5x plus 21. So the one of the new number becomes, so after this one of the new number becomes twice the other new number. So twice the other new number, children will see here. Wait a minute. Okay, let us see now. Yeah. So you can see the positive number is 5x. So another number is x. Now according to question is, if 21 is added to both the numbers, then one of the new number becomes twice the other new number. So 5x plus 21 is equal to twice the another new number. Another new number was x plus 21, right? Twice of it means you can see 2 times x plus 21. So here is our equation now formed, that is 5x plus 21 is equal to 2 into x plus 21 in bracket. So let us now solve this. Let us first open the bracket which is there on the right hand side. So here it is 5x plus 21 equal to 2x. 2 multiplied by x will be 2x plus 21 into 2 will be 42. So here it is 5x. So now we are transporting 2x to the left hand side and 21 to the right hand side. That is, we are bringing the terms which consist of the variables towards the left hand side and all the constants to the right hand side, right? So here 2x will be coming to the left hand side. It is plus 2x which becomes negative 2x. So 5x minus 2x will be in the left hand side and this plus 21 it goes here, it becomes negative 21 and 42 as it is. So it is the right hand side, the terms are 42 minus 21, which is nothing but equal to 21. And left hand side, 5x minus 2x will be 3x. So hence the term is now what we got is 3x equal to 21 is the equation. Now only 3 is remaining with the variable. So we transport it directly to the right hand side. So it is in multiplication form. If we transport it to the right hand side, it goes in division. So x will be equal to 21 divided by 3, which is nothing but equal to 7. So hence the another number which we have thought of, that is here you can see another number we have taken as x. So what is the x value, children, now we got? It is 7. So here you can write in the answer another number is equal to 7, and the positive number, what are the numbers? We have to find both the numbers, another number as well as the positive number. So positive number is equal to 5x, that is 5 into 7, substituting the value of x. So 5 into 7 is equal to 35. So 7 and 35 are the two numbers, that is 7 is the another number and 35 is the positive number, right? So this is how we have to solve. First we have to form an equation and then solving will be very easy now for you children. Alright. So both the methods you can use. Either you transport the terms or constants one by one, or the other you balance the equations by adding, subtracting and division and multiplication on both the sides. So whichever you feel easy, children, you can try that, right? So today we will stop over here, children. In the next session we will again continue with our exercise 2.4. So that's it. So today we will stop here. Thank you. Bye bye.